This video is based on a work that my friend Dylan Hancock from Tampa did on impossible travel rules. So we're going to see why this is important. But basically, impossible travel rules have to do with the fact that a user logs in from an IP that gets translated, and more on that later, on a location 1, and then a short period of time later he logs in from another IP address that points out to another location 2, where these two are too far apart, and this denotes that his credentials are being stolen, because nobody can travel that fast between two places. This is specifically important when your organization is a target of choice. If somebody's aiming at attacking your company, let's say that this is the prelude of a ransomware campaign, where the attacker, enjoying the impunity that will give them that he's working from another soil, well, he will not be prosecuted. It's going to be getting a machine in the country that he is attacking. So let's say that you're in the US, he's going to get an account in the US. If you're in Germany, he's going to get an account in Germany, most likely by using a cloud provider that operates into your country. And so why do they do that? Well, in order to render things like UBA ineffective, because it's going to look like the login, let's say that it's a successful login because your credential has been stolen, is coming from the same country. So all the rules they say when it comes from this country or that country, they're not going to fire because they're actually coming from the same country. Unless you have an attacker that is so dumb that he will do it from his own country. But people are getting better in there. So you have the real user in a location or city 1, and you have the attacker coming from another city in the same country, city 2. But what the attacker will not be, or it will be very hard or harder, that this is a race, an arms race, and you're trying to raise your defenses as the attacks get better. What it will be hard for the attacker to do is to find an IP that will be close enough to the real user place, right? So if it's an account in the US, well, maybe he's doing it from Dallas, and the account is in Colorado, so there's no, and within a few hours or a couple of minutes or whatever is the time, and more on that later, it's going to be detected as an impossible travel rules. Now, the implementation of this, and this is what these videos are all about, has some complication, and that's probably, and this is my take, why IBM has not created rules out of the box to deal with this, because this needs some tune-up on every customer. So for once is, people work from home now more than ever, or maybe they may move into an office an hour later or so, or maybe while they are in office or at home, they may be using his cell phone, his or her cell phone, to get the email, and that is going to give the IP address from the telco, which might be, many miles away from where the user are. So this needs to be tuned up to make sure, and I'll show you how Dylan did all this, how you tune this up to make sure that this doesn't give you false positive. Another source of complication. Well, some of the services that you use are from cloud providers. You have AWS, you have Office 365 from Azure, etc. Or any other provider. So what you need to do is that you need to make sure that the IP ranges for those services from those providers that you are using, they are put in your network hierarchy in order to filter all these impossible travel rule when the traffic is remote to local. As you probably remember, and there are videos that shows how you deal with this. Anything that you put into the network hierarchy is considered local. And you want that because when the user is logging from Office 365, well, you consider that part of your network, right? And you do that by putting that into the network hierarchy. But that's something that you need to do, otherwise you're going to get false positive. The other thing that can happen, and these are just some of the complications that we have seen here, is that you may have an employee that is on vacation traveling overseas. And he or she may be using his or her cell phone to check his email from whatever country he's visiting that is outside the country where he or she works. So you want these to fire only once, the first time that this is detected. And we will see that we can accomplish this by using a reference set with a time to live of, let's say, 1 month, in order to make sure that, if the first time it fires, well, we check out, yeah, this guy is on vacation, that's fine. So that's going to stay there for a month. After a month, that is going to be dropped from the reference set. And next time that happens, it's going to flag. Another complication that could happen is that keep in mind that your cloud and your telco could change IP addresses at will, and they're not going to tell you about it. So you may get a search on false positive because of this. So you will need to adjust your network hierarchy accordingly if you start seeing this, right? So, and you see, because of these complications, I think that's, but this is my take, that IBM has not provided that. But QReader has the tools to implement this. And those tools are basically 2 AQL searches. And we're going to be using those two here, and I will explain them in great detail. And everything I'm providing here is going to be in a box folder. I'll point to that later, so you don't have to really understand much about it, but you can just use them. The first AQL function that we're going to use is going to be called Geo Lookup. You can look in the API documentation. Everything that I'm going to be working in this video series requires you to have the mind map database well connected and updated. I made a video that shows how you do that, and here is that video. Again, as you know, there's in this link that is in the video description of all my videos, there is a PDF with files in there. Also in this link is where there's going to be a folder called Impossible Travel from Dylan, where you find everything to import and get this ready for your system. But you will need to tune it up, but all the heavy lifting is already done there. I did not mention on that video is that an easy way of making sure that your geodata is up to date and is working well is by issuing that command. So you SSH into the QReader console and you issue that command, and in my case I should get a no update available because it is up to date. So you should get something similar. If you have a problem with the user ID and password or whatever it is, you can deal with that. But this requires that mind map database is actually working. Because that Geo Lookup, when provided with an IP, that AQL function is going to give you that location, right? The other AQL function that we will use for this is called Geo Distance, and you may actually get an idea of how that works. So basically, this AQL function, when provided two locations by virtue of two IPs, is going to compute the distance based on that MaxMind database in kilometers. No big deal if you are used to miles. Now, the rules that help you make this happen are two. You need first, this is the way that Dylan did it. I think it works very nicely. So you get rule 1 that actually populates a reference table. So every time a user logs in successfully, and what I mean by user successfully is that the logs needs to be categorized as authentication login. So anything, it can be Office 365, it can be logging into whatever. If the parser is properly written, the DSM is properly written, the category of that event is going to be successful authentication, and then these rules will take effect. So what it's going to do is that it's going to put into that reference table, the key is going to be the username that just authenticated, and it's going to put in there the IP address where he did it and the time it did. So every time somebody is authenticating, boom, 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 that table is being actually populated automatically. And then there's going to be a second rule that is going to compute the distance using that second AQL function. And also it's going to compute the velocity from going from one, what velocity you will need to travel to go from location one to another. And of course, it's also going to measure the distance between the two. And that is going to fire an offense. Notice that the first rule doesn't fire an offense, just populates that table. But this one will fire an offense once the distance or the speed is above a limit. And I'll show you how you actually play with that limit that will make it physically impossible. And you tune it up with these constraints that we mentioned in here. And then it will also, this rule, besides firing an offense, is going to add a user to a reference set. And you can set that reference set with a time to live of a month. And this is what you can actually use to maybe UVA, or if you want this to fire only the first time that the user is detected and you investigate it and you don't want that to fire again, you can do so. Part of this package, if we can call it like that, this is of course unsupported. This is not an IBM thing. This is something that can save you work. So don't use it and then call IBM support. They will not know what you were talking about. But also in this package, it's included a nice search that will allow you, once the offense fire, you can actually see all the places where the particular user has actually logged in from. Okay, so I'm going to pause this video. This is being long enough. In the second part, we're going to show you how you implement this into your system.